Okay, this is the 3.3 to 3.5 review. Calculators still are not allowed, and this is the free response problem that goes with this portion of the test. So, on part A, we are given a function that is the position function, and I'm asked to find the velocity and the acceleration based on that original function. So, hopefully you all remember that velocity is the derivative of that position function. So if I take the derivative of this function, the first thing I hit is secant. So the derivative of secant is secant tangent of the inside unchanged, and then I have to multiply by the derivative of the inside, which is e to the t. So when I look here, I see that I have three things multiplied together. So before I launch into taking the derivative again, which is what will give me the acceleration, I'm going to take a quick little sidebar with a simpler. I know you could figure this out on your own, but just in case, I'm going to do it for you. Let's say I have a function that is three functions multiplied together, and I want to take the derivative. Well, we know our product rule, so we could clump this one as our u and this one as our v. So f could be our first function, and g and h multiplied together could be our second function. So the derivative, according to the product rule, would be the first one times the derivative of the second plus the second one times the derivative of the first, which is f prime. So now let's look at the derivative of the second. The derivative of this g times h will require another product rule. So that will be the first one times the derivative of the second plus the second times the derivative of the first. If I now distribute, we can see that when I take the product rule of three things being multiplied together, I end up with three terms. And each of those terms has two of the unchanged functions and the derivative of the third. So notice I get an f prime, a g prime, and an h prime. So each one of these gets a derivative one time, and then the other two are unchanged in the three terms. So you can see how this is just an expanded version of our normal product rule, which has two terms. You end up with, or excuse me, two factors, so you end up with two terms where one of these has a derivative and then the other one is left alone. So if I had four, I would end up with four terms. Three of the functions would be left alone, and the fourth one would have a derivative, and each of the four would get one term with the derivative. So based on that, let's go back to what we're doing in part A. I need to take the derivative of three things that are being multiplied together. So I know I'm going to have three terms, and each of those terms will have two of these unchanged and one of them with the derivative. So let's do a template to get us started. And we know they need to be added. So let's do a secant and a tangent unchanged, and then let's do a secant and an e to the t unchanged, and then let's do a tangent and an e to the t unchanged. So now what's left to do is to take the derivatives of the third term. Well, the derivative of e to the t is just e to the t. The derivative of the tangent term is a secant squared of the inside unchanged times the derivative of the inside. And the derivative of the secant, we need a little more space for that one, is a secant times a tangent of its inside unchanged times the derivative of its inside. So pretty messy, pretty long, but we don't have to simplify it. We're done. So if we look at the points that are available, we get 2 points for taking the derivative the first time, and we get another 2 points for taking the derivative the second time. And I will warn you that this review is much more challenging than the original function. The one that you'll have on the test is simpler than this. It's not as hard. So now let's continue on to B. B says, at what time does the particle first have 0 velocity? So my velocity, which was secant times tangent times e to the t, needs to equal 0. Well, here we've got 3 terms multiply to give me 0. The only way that can happen is if one of the terms, one of the factors, equals 0. So hopefully you remember that secant looks something like this, and it never crosses the x-axis. So this will give us no zeros. E to the t, hopefully you remember, it looks like this. It also never crosses the x-axis. So this too will give us no zeros. So that means my only option available is this one. The tangent crosses the x-axis at every variation or multiple of pi. So we'd have 0, we'd have pi, we'd have 2 pi, etc., etc., etc. So if we go back up to the beginning, it tells us that t is always positive. So my first time when the particle has 0 velocity can't be 0, so it must be pi. So we can write down the time that we first have 0 velocity is at t equals pi. Last part, C, says what is the acceleration at this time pi? So let's think about where this came from. Oh, I lied. It's not t equals pi. It's e to the t equals pi. It's the inside of that tangent has to equal pi. So e to the t will equal pi, which means that t will be the log natural of pi, which makes much more sense. So if we look at part C, it says, what is the acceleration of the particle at the time determined in part B? So if we think about this time and the insides of my acceleration graph up here, they're all e to the t's, e to the t's, e to the t's. So if I plug in an ln of pi in for t, that'll be e to the log natural of pi. Well, that's just going to be pi. So we'll have the secant of pi times the tangent of pi. But we just figured out down here that the tangent of pi is 0. So because the tangent of pi is 0, that means this entire term is going to be 0. This one won't be, but this one, since it's got a tangent in it and another tangent, this one will also be 0. So the acceleration at that log natural of pi is only going to come from this interior term here, because everything else is going to disappear. Tangent of e to the ln of pi is pi, tangent of pi, which is 0. So that means I'm left with the secant of e to the ln of pi, that's the secant of pi, times the secant squared of pi, times an e to the ln of pi, which is pi, times an e to the ln of pi, which again is pi. If we simplify this, remember secant is the reciprocal of cosine, and the cosine of pi is -1. So I get a -1 times a -1 squared times a pi times a pi. So we end up with a negative pi squared.